This conference will now be recorded.
So, good morning. So, tell about how to create the containers. How do we make sure the containers are so mapped, and how do we contain applications? That's very important. Well, but what if containers? For example, I have some containers. Yesterday, I shown you some application container. Application container. So that application container. So due to some reasons, and which is down, right? So the container itself is down. Now the container itself is down. The question is, how do we make sure we run the container again, right? So now here we are talking about container high availability. So container high availability. Let's talk about this container high availability, how we can provide the container high availability, or else how do we deploy the containers in, say, container orchestration. Orchestration. So how we deploy the containers, how do we orchestrate the containers, how do we make sure the containers are high available. So to answer for all these solutions, which is Kubernetes. So let's talk about Kubernetes and how can we have containers provided high availability. So that is the basic idea. How do we deploy the containers? So that is the concept. Right. So before we look into Kubernetes technical things, let's understand its orchestration, so architecture. So what is the architecture does Kubernetes follow? And then, so what is a Kubernetes cluster? So this is an very important thing. So cluster. So definitely there will be questions on the Kubernetes architecture or Kubernetes cluster. 100% there will be questions. And Kubernetes clusters or Kubernetes architecture has some uh, components. Okay. So basically, what is the architecture of Kubernetes? Kubernetes architecture is master-slave architecture. Okay. So the master-slave architecture. So it's like a general master-slave architecture. We have seen the architecture in terms of Jenkins. Jenkins follows the same kind of master-slave architecture. So we talk about the architecture again, but in terms of Kubernetes. So we already know this architecture in Jenkins purpose, but here we're going to discuss in terms of uh, Kubernetes purpose, containers purpose, how we can have setup, cluster setup. So I think you know basically master slave architecture, so the basic architecture. So it's kind of any kind of architecture. So we have some components. So we talk about the components. So we have different components. So running on master and also slave. So what is the components? We talk about those components now. So begin with the architecture. So the major idea between master slave architecture is high availability, right? So we know that. Well, so based upon that idea, we'll see how that architecture can be provided, how the cluster works for Kubernetes. Right. So first we have Kubernetes master. So I have some server here, and then so which has Kubernetes installed. So I'm going to install Kubernetes KX. So KX is a shortcut for Kubernetes. You can call it KX or Kites or Kubernetes. Right. So we have KX, and then what do we install on the master? Okay. So we install kubeadm, nothing but kubeadmin. Okay. So once you install kubeadmin, and then So this is what we call our Kubernetes master. Okay, so we talk about Kubernetes master. So nothing but, so in Jenkins master we install Jenkins. The same thing here. In Kubernetes we install kubeadmin, and on the master side and server side, that is what is your Kubernetes master. Okay. So your master has some different components. So what components it has? So first it has API interface. Okay, API. So you can call API, you can call it. So API manager, actually call it. So API manager. Okay. So then we have the other component. Just a second. So these are, we are talking about components now. So let's talk about the components. And these are the components. So the first component is API manager. Second component is control manager or controller, you can say control manager, controller. And then you have the third one, and which is scheduler, and the fourth one is etcd. So these are the different components. Now what are the purpose of these components? When these components are installed, these components install, so whenever you set up the kubeadmin, I mean once you install kubeadmin or kubeadmin, install all these components. Okay, we talk about these components. So meanwhile, so this is your master side. So whenever you have master, as usual, you have the nodes. That is the cluster, right? That is what is the master slave concept. So then here we talk about slaves. We can call them slave, nodes, whatever you call it. We have slaves. You know that. You know terminology. These are the nodes. Let's say I have 3 nodes. You can call them agents, slaves, agent. You can call them worker agent as well. So whatever you call it. Okay. So worker agent, or nodes. Okay. But don't get confused with their names. Okay. So we have master slave, we have master, and also we have slaves. Well, then, so what is the purpose of these slaves? The purpose of the slaves is, so here I want to create a container, let's say, right? I want to create a container. So if I want to create a container, then, so where do I create the containers? Your master creates the containers on the nodes. So master creates the containers on the nodes. So now why master creates containers on the nodes? Again, the same reason. It has to manage the load. So if you have containers running on same master, then container won't be able to manage it. The container status, or you can say the load on the container. So that's why we run them on the nodes. Okay. So once you run them on the nodes, then so here you have containers running on the nodes. Yes. So who creates the containers on the nodes? Master creates. Okay. Now there you have containers running on the nodes. But your container will be running on the nodes within a pod. Here we have a different terminology. We call it a pod. What is a pod? Pod contains your containers. Pod has your containers running in it. So there you have containers. So within the pod, you can see the containers there. These are the containers. So there you have container running. So why my container is running in a pod? The container is running in a pod. So here we have a container. Okay. So why the container is running in a pod? so that pod makes sure the container status is always running. Okay, so that is the purpose of a pod. Well, so here we have that is the purpose of a pod. Well, then moving on to, so who creates the pods on the who creates pods on the nodes, or who creates containers within a pod? So here we have, so scheduler. Okay, scheduler does it. Scheduler purpose is, so it manages, it schedules or creates the containers, creates pods on the worker nodes. Okay, so that's the first thing. Okay, so that is the first purpose of the scheduler. That's the first components. But now here we are talking about the components of the pod, components of the worker nodes. The first component is pod. Okay, so what is a pod again? Pod is nothing but it is a set of containers. So why we run the containers in a pod? Pod keeps the state. Pod makes sure that container status is always running. So if, let's say, for example, if the container is down, if the container is down, pod will again run your container, start your container again. So it works like you can say auto scale code. Okay, right. Then, so what are the other components? So running on the worker nodes. So here talk about another component, and the component is, this is very important component, which is kubeproxy. Kubeproxy. So what is the purpose of kubeproxy? The purpose of kubeproxy is, well, so take yesterday's example. So this is my application container, let's say, right? That's my application container. So who application has some users, right? Now the question is how the application can be accessed from the worker node within the pod, and my application is running in the container. Hope that was clear. So the concept is I have a container. Okay, that's my container, and container has my application. My application is running on a pod, okay, which is on the worker node. That, so there are users, application users. So they want to access the containers. That means the application. Now, how the users will be able to access the applications within the container running on a node, running in a pod, right? Well, so here we talk about, this is a very important concept. The concept is containers run your pod. Okay, let's say pod. The pod will be running as a service. Okay, so what is a service then? A service is nothing but your application, okay, or your pod, your container, whatever you call it. So your application can be accessed via pod or a container from outside, so that so users will be able to run the applications. So users will be able to access the application from the container or a pod. In terms of what? So here we talk about service. Service. Okay. So what is a service? An application or a container or a pod, you can say whatever. A pod can be exposed as a service, so that so it can be accessed from remote locations, because pods cannot be accessed from remote locations like a container, right? So that is the reason. So we must expose them to an external users, to outside world, you can say, and as in a service. Once pods or containers exposed as a service, the application can be run as application can be accessed as a service. Okay, right. So how we can expose the containers or pods to the outside world as a service? Then we need a component which is kubeproxy component. The kubeproxy component is useful to expose your pods to outside world as in a service. So that is the purpose of kubeproxy. Here, these two kubeproxy service are important terms. So remember them because we're going to discuss different services. With different type of services, we'll talk about services. But hope that is clear. Now, other components. So as usual, we are running and Docker containers on the nodes. So containers must have Docker installed. Yeah, that is another component. I'm sorry, I'm talking about worker nodes. Okay. So worker nodes must have Docker installed in order to run the containers. Right. And other component. So this is kubelet. Kubelet. So what is the purpose of kubelet? Why we need a kubelet? So kubelet, so make sure, so it helps us to monitor your container status. So for example, I have a particular container so running in a pod. So if you have container running in a pod, your container might be down. If your container is down, who is going to monitor the status? Okay, well, so that is kubelet. Yeah, well, so and then so the other type of components is so we have components, we have seen controller. Now what is an API manager? API manager is an interface so between the user and the your master. Okay, so API is API manager, you can say API manager. So make sure that so it works as an interface between your master and then user. Of course, what do you mean by this? For example, let's say I'm writing some manifest over here on the master. I'm writing a manifest. So what is a manifest then? Let's write a manifest. That means you can say manifest or your configuration file. So what manifest has? Manifest has your, so that means I'm creating a pod. Okay. And then, so what is the version you're using? Okay. What is the API version? That means what is the Kubernetes version? Okay. And then what is your image? The image name. And then, so mention your pod name, give some pod name and your container name. So your manifest has your configuration file has all this information. Okay, it has all this information. Then, so whenever I run my manifest, then what happens? So your controller, okay, scheduler. I'm sorry. So the scheduler is going to create pods and containers on the nodes, worker nodes. Who does that? Scheduler does it. Now, as a user, what is my responsibility? My responsibility is to create a manifest, run the manifest. So since you are running a manifest, you need some interface between your master and the user. That interface is provided by the API manager. Otherwise, so we don't understand those. So Kubernetes commands, even system does not understand the Kubernetes commands. Yeah. So that's why we have this API manager. Okay. So it's like it's an interface, you can say. I think basically what is the interface? Okay. Well, it's a control plane, you can say, which controls your commands, which has the full control of your master. Okay. Well, so that is your API manager, and then so that's we also understand even the scheduler purpose. Okay. Well, and then what else we have? We have also controller, right? So let's talk about controller. So now what exactly controller does? The controller is going to what we call like assign the jobs to the slaves. Okay, it's like controlling the processes. So what do you mean by controlling processes? So it reduces the complexity. Okay, it reduces the complexity, and which are compiled into one single binary. So run as a single process. So, for example, let's say we have some manifest. So whenever we have some manifest, and that manifest is when we run it, and it is going to controller is going to so notify the node. Okay, notifying the node. Okay, saying that so there will be there is a manifest we have, and then there's a pod needs to be running. So it is going to simply you can say it is kind of a communication running between your master and the node. So it maintains the communication, simply you can say, in other words. The master and the slave communication must be happening always. If the master slave communication must be maintained, then controller takes care of it. Okay. So that's in basic terminology. But internally, what exactly master does or controller does? So controller is responsible to divert it, to make sure your jobs are divided into the nodes. Okay, so that's the purpose of the controller. So if you don't understand it, so it manages the cluster and then make sure the cluster running smoothly. How the cluster can be running smoothly? By distributing the jobs to the nodes. That's it. By distributing them, you can call it. Okay, well, so that's the controller. And then finally we have etcd. So what etcd does? So etcd maintains the whole cluster information. It maintains the whole cluster information. So what do you mean by whole cluster information? So I have master, I have some nodes, right? I have master and then I have some nodes, and then also between these, okay, there must be some type of keys. We talk about the keys, of course, we'll talk about it. But so it maintains the whole cluster information, simply you can say your master information, node information, and how the communication is happening between them. Okay, and if you have any kind of backup plans, how the backups are taking them. Okay? So it maintains the whole information, the cluster information, etcd. But so these are the major components. These are really important components. Okay, and so which are used in the Kubernetes clusters. So without these components, there is no Kubernetes cluster. So first you have master, then you have nodes, and on the master you have API manager, then you have controller, scheduler, etc. API manager is an interface between your master and then user. So it's a control plane you can say, and controller makes sure so purpose is distributing your jobs to the nodes, distributing. Okay, so and it makes sure the cluster runs with high availability, and scheduler responsibilities to create the pods and the containers on the nodes, and etcd maintains your whole cluster information, that means your master and the node information. Then your worker nodes, we have pod, and within the pod you have containers. Pod is a collection of containers, and which makes sure that containers are running with high availability. Then proxy is used to expose your pods to outside world and as a service. Okay, why we use a service? What is a service then? Service is service is used to access the applications to the outside world, expose the applications to the outside world, which are running in a container or a pod. Okay, well, then you have Docker. Of course, we need Docker to run the containers, and Kubelet makes sure so within the pod and your containers are running state. It keeps checking the container status. Simple. If the container status is not running, it is going to again start the containers. Okay, so it is clear. Now, this is what is our cluster. So that's our Kubernetes cluster. So we must set up this cluster. So Kubernetes cluster. Okay. And which is very important, and so sometimes it might be a bit complicated, so which is important. Okay, right. Now, so we have master, right? Back to the master. On the master, I have installed kubeadmin. Okay, then that is our master. Wherever we install kubeadmin, that's our master. Okay, so I've installed this kubeadmin, but the question is how the communication is maintained between the master and the node, right? So how your master understands that is the node. Yeah. So just like in Jenkins, so when you have Jenkins master and Jenkins node, right? So there will be some communication happening between them. How the communication happens? Through SSH. And we install some SSH plugins, SSH slaves plugins. So those plugins maintains the communication between master and the slaves. Okay, that is through the plugin. Here, how the communication happens between them, right? Or how your master knows. So that is the node, right? So here we talk about how the cluster can be set up, how master set up with the help of kubeadmin. Okay, fine. But how this node is being set up as a node of the master, as a worker node as a master, right? Now, in order to maintain these two, your master and the slave setup, and master has an token. When we install kubeadmin, it is going to generate some token. So it will be generating some token. That token, I will be copying that to the node. So when the token is copied to the node, then your node will be acting as your worker node of the cluster. So I'm copying that token to the multiple nodes. Then these three nodes will be the part of the cluster. You can call it token, or you can call it a key pair, a token or a key pair. Clear? Where is that key pair is maintained? So that is what is said in etcd. Etcd maintains the key pair. Okay, so now this is the purpose of the token. The purpose of the token is so it helps us to set up the cluster. So you have master and then you have nodes. The cluster setup is done. Okay, right. So this is our whole cluster. Then so apart from kubeadmin, so what kubeadmin does, kubeadmin is purpose is to set up the master slave architecture. Okay, that is fine. But so kubeadmin, what kubeadmin does again, kubeadmin is responsible to run your master. Okay, fine. But so 1 second. API. Okay. Now you see the cluster, right? So on the cluster we have kubeadmin, then we have nodes. Okay. So instead of setting up this cluster or kubeadmin on server side and then workers on different nodes, can I have one single instance where we can have whole cluster running? So here we have one server and we have 3 servers for the nodes purpose. So this is our cluster. Instead of it, I have just only one server. The same server is going to act as master as well as slaves. So is it possible to do it? Yes, that's also possible. Okay. So how we can have your master slaves running on same single instance? In that case, what we are supposed to install? Kubernetes has a concept called minikube. What is that? Minikube. So what's the purpose of minikube? Like I said, local cluster, you can say. Cluster running on a single instance. Okay. So that is another kind of setup, but which is not preferred. So you can try that minikube in cases if you want to set up a local cluster, and that too only for practice purpose, not at real-time purpose. In real time, you have clusters like this. Okay, right. So what are those steps and how do you set up the cluster? We talk about that now. We look into the cluster setup. So here, let's talk about now. What are the components again? Your master components are API server, API manager, then you have scheduler, and then you have controller, and then etc. So then you have slaves or nodes, you can say, worker nodes. So worker nodes has a pod. Pod has containers in it. Okay. So this, remember this is a very frequently asked question. What is a pod? So pod is set of containers which runs on the node side, and pod makes sure the container status is running. Okay. Keep track of the container status. If the container is down, then pod is going to restart the container. Right. Then the other components are Docker is another component. Then we have very important component which is kubeproxy. So this is the second important question actually. So kubeproxy, and kubeproxy helps us to create the services. Okay. Then the follow-up question is, what is a service? Okay. So service is used to access your application from outside world. Okay. If you want to access your application from outside, we use the services concepts. Okay. So application, when it's application means I'm talking about pods. Okay. Since we have pods and pods has container has applications. Okay, make sure. Well, then what's other one? Kubelet. Okay, kubelet. So kubelet makes sure keeps checking the track of the keep tracking the status of the containers. Okay, well, if container is down, the kubelet is going to notify the pod. Then pod is going to restart the container. Simple. Okay. So then coming back to the architecture again. So for example, take this example. I have a manifest study. I want to create some containers. I want to create some pods, and that is my image, so and so. Then what I do next, I'm going to run this manifest. This is just a script, right? When you say manifest, this is a script. Okay, the script is written in YAML, the YAML script. We write the manifest in YAML scripts. And once you have the script ready, so what do we do next? So we'll be proceeding with uh, running the manifest. How do you run the manifest? So we have some commands provided by Kubernetes. So there are Kubernetes commands. How these Kubernetes commands are run? The Kubernetes commands are run using a command line. What is the command line is kubelet. Sorry, kubectl. I'm sorry, kubectl. So what is a kubectl? Kubectl is a command line provided by Kubernetes using which we run the commands of Kubernetes. Okay, so don't get confused between kubectl and kubelet. Okay, so that looks similar, but the purpose is totally different. That's why this is a comparison question: kubectl versus kubelet. So kubectl is a command line runs on the master, which helps us to run your manifest. Okay, and whereas kubelet is an component running on the slave side, which keeps tracking of your containers states. Okay, there's a lot of difference. Now let's proceed with how do we set up the cluster. Okay, let's try that now. So moving on to, I'm going to take 2 instances to set up the cluster. Let's log into my account. So let's load that. Anyway, we need 2 instances, launch instances. So I will be using uh, other instance. I will be using for board. So, I would go with Ubuntu. Let's go with try with Ubuntu. And let's go with t2.mic instances. So that will do. That's not a problem. Okay. So next. Launching 2 instances, 2 number of instances, and I'm launching everything on default network. So that's on default network, everything. And then, so if you want to launch node on one instance and then node on one network and master on another network, that you can so use network peering concept, VPC peering concept. Then only the cluster setup can be done. Otherwise, cluster setup cannot be done. But so go with the storage and the default storage. Then so give name to the instances. Name is equals to let's say Kubernetes Kubernetes say and ours it's in as Kubernetes master. And then so you can set up different types of rules, but I'm going with all TCP rules. So go with launch and then the key pair. The key pair, set it, and then launch instances. Now let the instance be launched. Go with the instances. We have 2 instances. So they are launching. Let them be. let them launch. So in the meanwhile, I'm going to grab my Kubernetes document, installation document. So we'll be sharing it. Just looking for my Kubernetes document. So are they ready? The instances, let me check them. I think so. It is ready. Well, so but we have two instances, right? Let's check them. And then just close that. So where are instances? I just only filter the running instances. So we have two instances Kubernetes master. Let me rename another instance Kubernetes node. Let's say Kubernetes node 1. Okay. Right. So now first, so take the master. We take the IP address, both IP, the IPs. Okay. Avoid the confusions. We just get the IPs. Okay. Just scroll this thing up. So that's IP address of the node, Kubernetes node. That's node IP. And then so we have master IP. So this is master IP. That's master IP. But so log into the master first, and then we perform the required steps to install that cluster. That's our IP address, and then change the appearances. And then SSH goes for the key. That's a key. And then login. The user is Ubuntu. The user. And then switch to super user. That's our master. And get login to the node. new session and then node login. Let it be black screen. The screen of the node is black and the screen of the master is white. Okay, and then login. So we have two instances. One is our master instance. That's our master instance. The second instance is our node instance. The black screen is the node and white screen is the master. Right. Going into the installation steps. So take the document. I will be uploading this document. However, one second. Let me copy and then document different folder. So I have like that so I've changed my system and then all my documents are not available on the system. That's why I've downloaded from the Google Drive. So of course even you can access the same file. So probably I'll just save it in some drive over here. Then just also make sure you copy the document. Okay. Anyway, so moving on to first go with install Kubernetes. So every step is provided here, and you just follow the steps to set up your cluster. Okay. Just follow the steps, so things will be okay. So now, so install. What do we install on the master? What we install on the node? So Docker. So we know these components, right? We have discussed them anyway. So we have discussed Docker, and then we discussed kubeadmin. So and then kubelet, kubectl, kubectl is a CLI, and kubelet is a service program on all nodes, handle the node level operations. Okay, so like make sure about the status. And then kubeadmin, so this provides a CLI for this. But anyway, now what do we install on the master? What do we install on the nodes? Now all these steps, you run them on both. You run them on the master, also you run them on the node. Okay, so these commands, the steps, whatever you see there, so you run them on both. You run them on the master, also on the nodes. And then when you scroll down, and I have provided some steps here, which you run them only on the master. And then, so the last step is, this is for node purpose. Okay, and then finally, you test that Kubernetes works, is my cluster has been set up smoothly or not. Okay, right. Now we're going to follow all the steps. So just simply, you can just follow the steps to copy paste them. That will work first 100% smoothly. So cluster setup sometimes a bit difficult thing. Okay, if you do any mistakes, so then I recommend you to do the steps starting from beginning instead of again debugging the steps. So that might not be possible. So start doing from the beginning. Okay. So first, so what do you do first? We install Docker, of course. So we install Docker. Now we run that install Docker on both, right? So both on worker nodes as well as some master. This is my master anyway. First update your repository, apt update. And do that also on the node. Where is the node? That's a node. Just apt update. And it's updated. Now we are on the master. So hope you're able to differentiate it. Okay, so please concentrate, differentiate by yourself. Now let's install. What do we install? Apt install. docker.io apt install, sorry, and so also install that on the node. Apt install docker.io. So now even on the master it's in progress, and on the node as well. I think it's done on the master. Okay. So check that service docker status. Okay. So it is inactive. Start that service docker start. And check the status now. So it's in running status. Okay. And then on the node, so check that service docker status. Then start it. And then check the status. It is active. Okay. So the first thing was done. Docker was installed on board. Then check the version. Of course, you don't need to check the version. It is installed. And then going with apt update, and then apt get installed. And so this is a package. So what is that? Apt install, and we have packages called apt transport AP HTTPS. Okay, copy that. Just install that. So why these packages are required? HTTPS, transport HTTPS packages. Okay. So since we are setting up the cluster, in between the cluster, so there is some communication happens, HTTP communications. So that's why this HTTP transport packages needs to be installed, and same time on the nodes. All that. Then I'm going to download some packages over here. So we call them, actually we are downloading apt key. Okay, we're downloading the key actually. So that key is required for our future purpose. So which is called apt key. Okay, we need that key. Download the key first. Copy that. So you get the message called OK message. And so this is you run even on the nodes, right? So these are the commands you run them on both master as well as slave. Then here we are on the slave. Message is okay. Well, then what's the next thing is you open this file. So what is the file name is etc apt sources.list.d and then kubernetes.list. Okay, open this file and then add this line over there. Okay, that is the line. So what is the file again? You can use cat command, and at the end of the file you can add, or else you just go with that etc apt. Okay, so try that etc apt cd etc apt, and then so you have a file called resources list.t. Okay, that's a file. So directly I mean, okay, resources list.t. Oh, this is a file, I'm sorry, it's not direct. Wait a second. Sources list.t. Okay, open that file. Then in that file should be a directory, isn't it? Just a second. Yeah, that's a directory. Then why I open a wrong file? Yeah, now we are correct. I'm sorry. That's a file. Now the file what we need is the file name is kubernetes.list. Open this file. The file won't be there by default. Open the file. Okay. So using vi file name, and then in that file I add that line. So that's a line. So why this is required? This is required to install the required packages. Okay, now that is one. Save it and repeat the steps on the notes. cd etc, and then what was the other one? etc apt, and then so sources.d, and then the file name is Kubernetes list dot, okay, Kubernetes dot list, I mean. So that's a file again. So Kubernetes list dot list, then open it, and then copy that. Okay, save it. Done. Now I think we need to update our repository again. Okay. Since this is added, the URL is added, so we need to update our repositories. Apt update. Then also same thing, apt update. So you see that it's taking it from Kubernetes. You see that? So these are the URLs which are added to the repository now. Okay, fine. Now going with apt install. Now what I'm installing? See that I'm installing kubelet, kubeadm, then kubectl. Okay, let's install them. Sorry, I think I have copied it. So just go with install them, kubelet, kubeadm, ctl. Now, so even repeat the same on the node. So this is installed. Okay, and then so put these services on hold. Okay, so that we can start the cluster is set up. So put them on hold. Put it on hold. So they are on hold, and also same thing on. Okay, hold. Okay, so now we have steps to perform on the master only. Okay. These are the steps needs to be performed on the master. Let's go with this. So now I'm initiating a kube API. Okay, initiate kube admin. So that's on the master. Let's initiate that on the master. No, it's not the one. We already have tried that. So kubeadm init initiate. So what was that error? Kubeadm init. It's using Kubernetes. Okay, that's fine. So there it is. The Kubernetes version 1.21. Okay. So initiated. You should get a message. Enable, yeah, enable Kubernetes. Okay. System read, please wait. Memory is less than the minimum 17 MB. Well, there is an error. Okay. So, well, I think we missed this point. So how did we miss that? Say if you want to run your Kubernetes master, okay, you need at least 2 CPUs. That's the first thing. And also you need 2 GB space, 2 GB memory at least. You see that that is what is the error. Okay, your master must have at least, so what is that? Two CPUs at least, required two CPUs, and then so 17 MB memory. But so we have type of instances we have selected was t2.micro. It's 1 GB and then one CPU. So that kind of minimum configuration does not work for Kubernetes. I think we missed it. Okay. Well, that's why the cluster setup will be. I mean, is a failure for the time being anyway. The master is not ready yet because it has thrown us some error. That's the minimum configuration is required. Now, so we need to launch those instances with so at least 2 GB. I don't need these instances anymore. So these are not useful. Okay. So even better, I just take the my node as well. Okay. So now what I do, I just terminate these instances. I don't need them. I'm going to terminate them so that I can launch new instances, terminate instances. Okay, so launch instances. So, and all the steps are same. So the type would be changed. Okay, so we'll be going with at least two CPUs. Okay, so two CPUs, right? So that is right. Median at least two CPUs and then so post memory. Right. So go with next. So do we have anything with? I think that will do for us. Instead of medium, I can go with a small instance. Okay, so yeah, that will do. 2 GB. Okay, that should be okay. 1,000. Okay, I think that will do. Okay, next. So tag name. Value is Kubernetes. Let's say new Kubernetes master. Let's say. So new Kubernetes master. Next, and then go with all the files. Launch them. Launch it, and then let's say keep there. So the instances. Oh, okay. How did I launch? Did I launch only one? We must need two, right? Come on. Okay. Let's need two instances, right? So next again. Into the small, where you get small, it's small. So one and two. I need two and two. P3 dot small. Okay. That's small. Okay. So next, click next. Then name. The value is, let's say, new Kubernetes master. Instead of master, let's say node 1. But so next, security groups open to all, and then review, and then launch, and the key. So we have these two instances now. Just a division. But do I need to refresh? Good. So this is the master in time before the scroll it, look at the IPs. But the best is selected. We take it from the thing. So we are waiting for the okay. That's can you just take that IP address as master IP address? Change the IPs now. So these are new instances. Okay. And then the node IP. So node IP. Okay, let's log into them. Start the existing installation process. Okay, address, then in change the settings. Switch to super user. Okay, that's the master, and then also the node. So a new instance, a new session login. Connection remote. One and SSH key. Here we have changed the font. Let's change the font. So okay. Now first master steps. So repeat the same steps. I'm doing it repeating the same steps. There's no difference. Master first we run the steps on both master and the node. First step is apt install apt update first. Apt update, and then we can install Docker. So we are in master now installing Docker. So apt install docker.io. Okay. Then apt install docker.io on the node. Okay. Then installing Docker. And also we make sure the services are running. Okay. So and service Docker start, and then so check the status. Plus on the node service Docker start, and check that on the status. Okay. Well, now Docker is run, and then now going with then apt-get install. So run these import packages, TPS transport packages. Okay. Download them and install them again. So and then repeat that on the node. Okay. So and those packages are installed on the master and the slave. Now, so other step was so download this. So key, download the key first, okay, which is what we call apt key. We are downloading it. Then go with the apt key on the node. Okay. And then so open the file. So etc, okay, that's a file. Etc apt cd etc apt, and then so cd sources.list.d, and then the file name is Kubernetes list dot Kubernetes dot list. Kubernetes dot list. That's a file. open it and run this and copy that. This is for downloading Kubernetes. That's the URL. Okay, downloading Kubernetes. Then, so repeat it also on the node. Okay. etc. Then, so what was that? The path. You can do the path exactly. etc. And then add. Okay. Sorry, on the master on the node, right? You should be careful of it. Yeah. And then cd sources dot this dot d, and then the file name is kubernetes.list. That's a file name. And then let's go with run this command. Okay. So add it, and now we can update our repositories. Apt update and node also apt update. Okay. Well, now we can install this. This is where we got failed, right? So when I was installing kubeadmin, so we got failed. Okay. So I think this is not the step we got failed. I think we failed in different steps. Sorry. So here we're installing it. These packages are installed, but when I initiate that kubeadmin, that is where we got failed. And then repeat that also on the node. And once they're installed, make sure you put them on hold. I'm just going to initiate them later. So now put it on hold on the node. Okay. Well, so now coming to the master. So we initiate that kubeadmin initiate the master, initiate kubeadmin, I mean. So it should be initiated. So okay. It says Docker service is not enabled, did we? I think we have enabled, right? Well, let me check this out. 1 second, just a second. Give them some time. It might be, so we have enabled it. I think I'm sure about that. Well, just wait for a second. It might be enabled by itself sometimes. Yeah, so it is enabled by itself. See that it is what it's doing. It's initiating API server, controller manager, and then scheduler, right? So the three components, the master components, are initiating. Starting kubelet. So first folder. It's not starting. Initial timeout. Okay. I think this is started. Yes. Now this is started successfully. Well, and it has given some commands as well to start your cluster. We run them, of course. That is there also in the document. So we'll be running those commands. So the same commands are provided here, are given the same commands. But anyway, now, so what happened now? It has provided this key. You see the key there? This is a token. So with this token, I will be running on the node to join the cluster. Kubedium join. This is a token. Okay. So this is what I said about token. So master generates a token, and we take the token, run that token on the node, so that cluster join can be done. Anyway, so anything else needs to be done on the master? Yes. So you must save that token. Okay. You must save the token. But what if I might have forgot to save the token? If you forgot to save the token, and what you could do, and you could generate a command called use this command. The command is so kubedium token create print join command. So this command regenerates the key if you forgot to save the key. Okay, or else in the future I want to join another node. Then you run this command, it generates the key, you copy the key onto the node. Okay, well, so then go with copy. Now I'm running these three commands. Okay, whatever the commands are provided here, these commands I'm running them. But anyway, just copy them here. Use these commands and then copy some files here. We are copying something called ADM config file to the home directory. And then also changing the permissions. Ownership is changed for those files, admin.config file, and then export kubeconfig file. Okay, these are the three commands. Well, that is the master setup done, and then you just run that command. Whatever the token has been there provided, run that command on the node. This is the command kubedm join command. When you run this kubedm join command, master will be node will be joining the cluster with this master. Okay, so back to the node. Okay, and then run that. Now it is starting that. Kubelet is starting. See the kubelet is on the node side. So the cluster run nodes to get the control plane anyway. But you say that this node has joined the cluster. Okay, the cluster is started, has joined successfully. Okay, so now is my cluster is running successfully. Now on the master, you just check this kubectl get nodes. Then if you see the node name, and that will be success. Could have been success then, but let's see kubectl. Now you see that I'm using kubectl command. Kubectl get nodes. Yes, that is my node. See that node IP address. So 172. So that just get the node IP is same IP address. Yes, that's a same IP. So it is joined the node successfully. Cluster has been joined. Okay, right. So now in cases if your node setup is not done correctly, you can use these three commands to join the node. So if you get that nodes list. So even after you run that kubedm join and the node has been, you come to the master, you see that kubectl nodes, but I don't see the nodes. Then you run these three commands. So these three commands, when you run it on the master, it is going to give you the nodes. Okay, right. But however, now I can see that is my node ready? 1 second. I just want to see that. So it's not ready yet, right? It's not ready yet. Yeah, well, so this is what I said. So if you want to run that nodes and there you see you run these three commands, then your cluster will be ready. Excuse me. So that's our cluster will be ready. Now go with it. So and then so this is the second command, kubectl get nodes. Now you'll be able to get the nodes. Not ready yet. Okay, well, still not ready. Let's see. Should be ready. Yeah. second. kubectl get nodes or kubectl nodes, whatever. Get nodes, of course, but the command, whatever, this needs to be you can do that. kubectl get nodes. Yeah, now they are ready. See that the cluster is right. See the status there. So that's the command. Okay, that's the last one. You still apply. So once you apply that, so and then you'll be able to run your cluster, start your cluster. Okay, the cluster has successfully set up. Now you can use the same commands again. You see that these are the commands I have given already. Okay. And so this commands over here I have given already. Now you can use these three commands again. If when you apply that, if apply is a failure, you use the same three commands which I have already run it. So just try that. Okay. So the cluster is successfully set up. Now I'm going to show you an example how we can launch a node. So hardly I may take about 10 more minutes. Okay. So since the cluster is been set up, so I just want to see the node when how to set up the cluster. Okay. But so cluster has been set up. Sorry, I want to launch a pod, a container. Let's see how we do that. Now, the pods or containers can be set up in using kube config file. Sorry, kube manifest file, sorry, Kubernetes manifest files. So that you can do it, or else you can do it through the commands. But anyway, today I'm going to show you running only commands, and tomorrow I'm going to show you how do you launch them through the manifest. So the commands, I'll show you the commands. Well, just scroll down. You can find everything in the document, the steps and everything. So for your future reference purpose, for practice purpose, either. So I want to go with the commands first. So these are the scripts. I don't want to go with the scripts straight away. Okay. Now in this document, so this is another document. This is my second document where you can find the scripts. In this document, I have also mentioned the mini cubes. If you are interested to set up the mini cube, you can set up the mini cube, which is a local cluster. But if you are interested, okay. And then now go with first. I'm going to check run this command kubectl run hello with cube. Okay. That means what command is. So this is like Docker. We are Docker run, right? Now here we have kubectl run. So the commands look similar to Docker. Okay. Instead of your Docker, we go with kubectl. So then go with it. Now this document I will be closing it. I don't need it. Then. So kubectl mini cube. Just copy that and I can explain. So instead of cubes, hello, I'm just changing my pod name. So what I'm trying to do, I'm trying to create a pod actually. Okay. So trying to create a pod. That is what is the command is regarding kubectl and the pod name. So what is my pod name is, let's say hello pod. That's my pod name. And then, so this is our sample image, which I will be using to run create the pod. That's my sample image. Okay, but so try that now, and then I'm exposing that to port number, which is 8080. Right. So we are running an image, and this is the image URL, and this is a Google image. Okay, Google sample image. So since Kubernetes is provided by Google, so we're using Google sample image. This is like in Docker we have used hello world image, the same kind of thing. And my pod name will be hello pod. Okay, but enter. Now pod hello pod is created. How do you see the list of pods? We have kubectl get pods. Now hello pod is created, and within that your container is created. Look at the status is container created. Okay, so your pod is now in Kubernetes, it's all about the pods. There is no containers. Of course we have containers, but containers runs in a pod. You cannot run container standalone. It has to be within the pod. Then so go with kubectl and then describe pod and the pod name. So what is the pod name is hello world is the pod name. Hello pod, I'm sorry. Describe pod and the pod name is hello pod. What describe does, sorry, that was a typo. Describe. Okay. So what describe does, describe gives you so what exactly happening with your pod. So first it was so successfully assign the pod, then pulling the image has been pulled. Of course we need images. Without images you cannot run the pods or containers, right? Now container, created container in a pod, and then you have container, so your pod is started. So what is the status of the container pod is, you can see the status again using kubectl and then get pods. So the status, the typing mistake, just get pods. Come on, kubectl, sorry, kubectl get pods. I can see the pod. Now again I like to describe that status is running. Again describe it, and in the describe status I can show you that. So there is, it's pulling the image, and that's your container ID, right? That's your container ID, and that's a port number. Okay, and that is a port number of the image, or you can say container. Okay, default port number. And then where this is running, so what is the host, I mean what is the node it is running on. I can show you that it's running on particular host, where you can see that. So there you see that host means in terms of, I'm talking about in terms of nodes. That's my node. Is the same node IP address? So check the node now. So this is our node. Yes, that's a node. Okay. Or else I can do the same thing here with the help of Docker ps command. We know the Docker ps command. Now list the containers. When you list the containers, and our pod name was, the pod was hello pod, that was hello pod, and the container was, that's your container. Okay, so we have pod and then we have container. It's running in a pod container. So how do I know that? You see the pod name, the pod name was hello pod, so my container is running in that hello pod. Okay, so that's your pod name and this is your container. Now, is it the same container? So try to find out, starting with 0407 something. So same container, that's a container, right? So it's all running good, smoothly, no issues. Yeah. Well, now what if, okay, I stop the container, then I want to stop the container. If I stop the container, so let's see, is it going to create a new container for us? So that is the concept of Kubernetes, right? So Docker stop and then your container ID, okay, enter. Now the container is stopped. Done. Now go with Docker ps again. Okay, go with Docker ps. I can show you that a new container is created about 4 seconds ago. Now here you have the new container. So that's your new container which is started about 4 minutes ago. Now is this new container starting with FA? So is it reflecting on my master? So let's see. So kubectl and then so describe pod again. Okay, describe pod, that's my pod name, and the new container has to be reflected. So there it is. Yes, starting with FA. Okay, well, now so containers running successfully, pods are running successfully, my container is running in a pod, it's all good. Well, that is clear. but I want to access the container from outside, or I want to access the pod from outside. So how do I do that? Right? So here we proceed with service, right? You remember the service concept? If you want to access your pod from outside world, then it has to be your service type. Service. I'm going to expose my pod to a service. And what is the service name I'm going to use? I'm going to use a service. The service name is, which is node port service. That's node port service. We are different services again. Service is node port. What do you mean by node port? So when I expose my pod to the port, through the pod, I'm sorry. So this is my pod, right? This is my pod. I'm going to expose that pod to the node. This is my node, right? Onto the node with some port number. Then as in a service, if there is a user, now the user will be provided with a URL with a port number, then he will be contacting the port number of the node, and so that is why we call it a node port. So users will be able to access the pod with the help of port number of the node. We call it node port, that's why. And to that node, or to that port, node port, and we have container, so link. So users accessing that pod from the node port. So we call it node port service. That's important. Okay. Well, so what is node port service? A pod is exposed to the port number of the node simply. So that you will be able to access that pod from the port number of the node. So we don't expose that. I mean, we don't need to provide the container information, pod information to the user. Of course, we never do it. So we provide the node IP, node port number. Then users will be able to do it. Okay. So this is like, you see, remember the port number -p concept, the same thing here, right? Docker. But in Docker, we map it to the host, but here we are mapping to the port. We are mapping to the host, sorry, to the node, I'm sorry. So there in Docker, we map it to the, with the help of -d, we map the container to the host. Here we are mapping the pod to the node. That's it. That is what we call port number, node port. Right. Let's see how do you do that. We have kubectl expose command. This is a command, kubectl expose, and the pod. Let's go with that. Okay. So kubectl expose pod, and the pod name was hello pod. Okay, so it is hello pod. Hello pod, and then type of this service. Mention the type. Okay, the type is node port is a service type. Remember these services. So 100% will be questions on the interviews. The services type, that will be 100%. Okay, hyphen type. So different services, we'll talk about them in the future. And the type is node port. So it is capital N, capital P, right? So in capital N, capital P, that's a service name. Now expose that pod. Now your service has been exposed. You can see that kubectl, and then now you can see the services now. You see that it's been exposed as a service. Yes. Now you want to see a service name, kubectl get services. Now you have services. My service name was, okay. So that's my service name. You can we give the different names to the services? We can do it. Okay, we can do it still. But and I want to also describe the service. Okay, go with kubectl describe services, and then service name was, so hello pod. That's the service name. Describe kubectl describe, sorry, services service name. Now, so that has been exposed to a port number. Okay. So which is, what is the port number is exposed to? You see that 31035. That is a node port. Okay, that's node port. You see that it is node port is a service. That's your node port. Okay, well, now I take that I take the port number and with IP address. Now I can, so we can try to access that from outside the port. Now, first if we need IP address, we can take public IP. Okay, just go with the node public IP. Go with the node public IP. And the port number I have exposed to, so which was 310 something like that, 31035. Okay, so enter. So this is your pod information. That means you got some message displayed regarding the pod. Since this is hello world image, right? So there's something. This is kind of hello image. I mean hello message. So what is that? Client address, something. Okay. So how this has been exposed. Some basic information. What is your host IP? All this information. If you're able to get this, means you're able to run your pod or access your pod as an successfully from outside as a service. The service name was node port was a service name. Okay. So now can we expose them to different port numbers? Now here I have exposed that to port number which is so 31035 by default. That's by default. Okay. Then how do we access that from different port numbers? Okay. Or how we can have different services expose them to. So everything we can check this out. Okay. We can do everything. But so what we can do, we can go with, so write some manifest over here if you want to do them. So he writes a manifest, then we can expose them to the different port numbers and different services. We'll talk about them later in the future. But however, so we just go through this document for today. So what you can do for today is the things you can do for today. First, set up the cluster. Okay, set up the whole cluster using this document. I'm uploading documents, of course, and your Kubernetes documents also will be uploaded to the uh, same Ansible. Okay, so same folder. So wherever you have Docker folder, in the same you also have Kubernetes document, and then you can see these all the steps. Go through the steps. You set up the cluster. Okay. So once you set up the cluster, and then so create this sample image for today. So a sample image was which is provided by Google. So you take that URL. Where is that? That's a sample image. Okay. So understand these concepts clearly, and what are the questions we can expect from today? So Kubernetes is totally important. So you can expect the architecture question and the components question. That's the second question. And the third question is the comparison questions, kubectl versus kubelet, and what is kubeproxy? Okay, what is the service? And then what type of services we have? We have seen a service called node port service. Okay. So and then other question was the services, right? Yeah, that is very, very important. So simply Kubernetes, every point is important like Jenkins. So Jenkins is every point is important. The same thing is Kubernetes. So it's all important. Okay. So get the cluster setup ready, then you can do hands-on, but make sure you whenever you set up the cluster, your instances must have your master at least. Okay, master must have so 2 CPUs and then also at least 2 GB memory, 2 gigabyte. So that's minimum requirement. So I did not realize that initially, okay? But now this is how you set it up. Okay. So clear? Any questions?
So we are set up the small. It is chargeable, sir.
Sorry. Yeah,
So
small
we
is yeah. Except
actually
micro, every instance is chargeable.
okay.
So if you don't want that charges, you can go with your virtual. But I don't think so. When you install this cluster setup on virtual, so like on virtual, the setup won't be successful. But you can try them. I've tried in the past, so but recently I have changed this document. So I came to know from some of my students that so these steps are with the help of these steps they're able to set up the cluster on the virtual VMware or Oracle virtual boxes. But you just try that, okay? So in the past I used to have a different document, different step, but those steps, those document, so not able to set up the virtual. But these steps, and you can set up that on virtual, I think so. But you can try that.
Okay, sir. Okay, sir.
So this is a new recently prepared this document just recently, about 4 months ago. So previously I had different steps. Those commands were not so feasible to set up the cluster on virtual. But these things, I think this will work and localize it virtually. Yeah. Anyone else? Any more questions? No. Okay. Well, thank you. I'll see you tomorrow.